Hi, judges! Welcome to another segment of One Arliwag Memorial High School Senior High School Math TV. For today, we will be discussing the degenerate cases of the hyperbola. Okay, so before we determine the degenerate cases of a hyperbola, let us first review or let's have a recap on what we have discussed involving degenerate cases. So when we have a circle, the degenerate cases of a circle would be a single point and an empty set. And just like the circle, for the ellipse, we'll still have the same degenerate cases. It could be an empty set or a single point. So for the circle, again, we have two choices. The degenerate cases would be a single point or an empty set. For an ellipse, we have the same cases, and that would be a single point and an empty set. So how about for hyperbola? What will be the degenerate cases if we are given an equation of the hyperbola? But before we discuss its degenerate cases, let us first determine when an equation yields a hyperbola. So we have here the general equation of the hyperbola. So this is our general form for the hyperbola. And it is ax squared plus by squared plus dx plus ey plus f is equal to 0. So as you can see, based on the given general form of the hyperbola, this is just the same with the ellipse. It's just that the sign of a and b will now be different. So they will have an opposite sign. If a is positive, therefore b will become negative, so that it becomes hyperbola. If b is positive, therefore a must be negative. A and b should not be equal to 0, because if a and b is equal to 0, therefore it is not anymore a hyperbola. Therefore, this 2 will cancel out, x squared and y squared will cancel out, and we will only be having dx plus ey plus f. Therefore, it now becomes a line. That is just an equation of the line if a and b are equal to 0. So let us now try to discuss first on how we will determine if an equation will yield a hyperbola. So all we have to do is to convert the general form into the standard form in order for us to determine if it is really an equation of a hyperbola. Again, just like the circle and the ellipse, if you want to know if it is really an equation of the hyperbola, all you have to do is to convert the general form into the standard form. And the standard form of the hyperbola are given. So this is for transverse axis horizontal, and this is for transverse axis vertical. We are given x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Remember that the right side of the standard form is equal to 1. For transverse axis y or transverse axis vertical, that becomes y minus k quantity squared over a squared minus x minus h quantity squared over b squared is now equal to 1. Okay, so what will now be the degenerate cases of a hyperbola? Actually, we have one, and that becomes the two intersecting lines. Therefore, this is now two intersecting lines. And why two intersecting lines? If we will encounter an equation of hyperbola which the right side is equal to 0, just like this one, all you have to do is to get its asymptotes. Again, these two intersecting lines are just the asymptotes of your hyperbola, if that is really the hyperbola. Okay? So, because in getting the asymptotes, we are equating the standard form of the hyperbola to 0 in order for us to get its equation. And those asymptotes will just be the two intersecting lines. Again, remember that if the right side of the equation that you got when you converted the general form into the standard form. Therefore, you are just getting the asymptotes, and those asymptotes will now be the equation of the two intersecting lines of the degenerate case of the hyperbola. Okay, so let us now try to determine whether the given equation now is really a hyperbola or it is not a hyperbola. So I hope that this is clear, that whenever you are given an equation of the hyperbola and the standard form is equal to 0, all you have to do is to get its asymptotes, supposed to be asymptotes, but then it will not anymore be the equation of the asymptotes because it becomes now the equation of the two intersecting lines. So let's now have this example. Okay, for this example, we are given 9x squared plus 126x minus 16y squared minus 96y is now equal to negative 153. So in this case, if we are given this one, okay, so if we are given this form, therefore all we have to do first is to convert this into the standard form. So in converting, therefore, we will be having, if that is 9x squared plus 126x minus 16y squared minus 96y is equal to negative 153, is to factor out the terms of the coefficients of x squared and y squared. So for this one, the coefficient of x squared is 9. So let's factor out 9, and this becomes x squared plus 126 divided by 9 will give us an answer of 14. We have 14x. And then, we'll now be having y squared. So for y squared, that becomes negative 16 times y squared. Since this is negative 96, y divided by 16, that becomes positive. And the answer would be 6y is now equal to negative 153. So this is now the time that we will be completing the terms of x and y. So we'll be having 9 times x squared plus 14x. 14 divided by 2 is 7. 7 squared is 49. So this is plus 49. If this is equal to negative 153, therefore we will be adding plus 49. But do not forget that 49 should be multiplied to its factor, and the factor is 9 minus 16 times, let's complete, y squared plus 6y plus what are we going to add in here? Therefore that is 6 divided by 2, which is 3. 3 squared is 9. So this is 9. So that should be plus 9, and do not forget the factor, and the factor should be negative 16. Okay, so in that case, we'll now be getting the factors for this one. So this becomes 9 times x squared plus 14x plus 49. That would be x plus 7 quantity squared minus 16 times, we have y squared plus 6y plus 9. Therefore, that is y plus 3 quantity squared. Okay, since this is negative 53, so let us try to multiply. 49 times 9 is 441. 9 times negative 16 would be negative 144. Okay, so for this one, if we have negative 153 and this is negative 144, so negative 153 minus 144, that is negative 297. Let's add that to positive 441. Therefore, the right side now is equal to 144. So in order for this to become an equation of the hyperbola, the right side should be equal to 1. Therefore, we need to divide all the terms by 144. Okay, let us now divide. And since we have 144 over 144, it now becomes 1. 144 over 9. Therefore, that becomes 16. Retain x plus 7 quantity squared minus 144 divided by 16. That is 9. The numerator would be y plus 3 quantity squared. Okay, since we have this equation, it is now in standard form. Therefore, that is x plus 7 quantity squared over 16 minus y plus 3 quantity squared over 9 is equal to 1. Therefore, if this is the answer, we could finally say that this is hyperbola. Okay? And if it is hyperbola, therefore, the major axis is the transverse axis x or horizontal. So the transverse axis is horizontal. And the center of the hyperbola is located at -7, -3. Okay, I hope that this is clear. So this equation is not a degenerate case of hyperbola. Therefore, we were able to know or to learn that this equation is a hyperbola and that the transverse axis is horizontal. Okay, so let's have another example. For another example, I will just erase this part. Okay. So for our second example, let us find out again if it is really an equation of the hyperbola. Okay. So let's have the second example. The given is 4x squared minus 4y squared minus 32x plus 8y plus 124 is equal to 0. Again, let us try to know if this equation is really an equation of the hyperbola. Okay, first step is that we need to factor out the coefficients of x squared and y squared, and in this case that is 4 times x squared, and this is -32. Therefore, that is -32 divided by 4. We'll be having -8x. Okay, next is for the y squared. Therefore, that is -4 times y squared. We have 8y. 8 divided by -4, that becomes -2y. Okay, is now equal to, since here is the constant, we need to transfer that out to the right side, and that becomes -124. Okay, this is now the time that we need to complete the terms of x and y, and this will be 4 times x squared minus 8 divided by 2 is 4. 4 squared would be 16. So that becomes plus 16 minus 4 times y squared minus 2y plus 1. Since -2 over 2 is -1, -1 squared is +1. Is now equal to 124 plus 16 times its factor, which is 4, minus, or that becomes +1 times -4. Okay, so this becomes 16 times 4 is 64. 1 times -4 is -4. Okay, so let us now try to factor this out, and this becomes 4 times x minus 4 quantity squared minus 4 times y minus 1 quantity squared is equal to, we have -124 plus 64 minus 4. Therefore, the right side is -64. Okay? So, let us now try to divide both sides by -64. Okay? So, from this case, you will analyze, why is the right side negative? Is it okay that the right side of the equation of the hyperbola is negative? Okay, in this case, it is not yet the standard form. Therefore, it is okay if the right side that you got is negative. Since this other two on the left, or on the left hand of the equation, one is positive and the other is negative. Therefore, we could say that we could divide both sides by -64. So divide both sides by -64, -64, -64. Remember that it is okay, since you still have this equation, one positive, one negative, and the right side is negative. It is okay that the right side is negative since we are dividing all the terms by the value on the right side. Okay, -64 over 4, that becomes -16. Retain the numerator x minus 4 quantity squared. negative 4, this is negative 64, this becomes plus 64 divided 4, that is 16, and then retain y minus 1 quantity squared is equal to negative over negative, same value, therefore that is now positive 1. Therefore, 1 is negative, 1 is positive. Let us arrange. We'll now be having y minus 1 quantity squared over 16 minus x minus 4 quantity squared over 16 is equal to 1. So in this case, we could say that this is really an equation of a hyperbola, and that the transverse axis is now y. So that is vertical. And so if this transverse axis is vertical, we could finally say that it is really a hyperbola. And the center is located at positive 4 and positive 4, positive 1. So that is now our center. Okay, so let's now have another example. Okay, and for the last example, so we now have this one. Okay, so if we have this one, therefore all we have to do now is to convert this equation into the standard form. Okay, in converting, again, the first step is to factor out the coefficients of x squared and y squared. So we need to factor 4. In this case, we have x squared and then negative 16x divided by 4. Therefore, that is negative 4x minus 9 times y squared. This is negative 18 divided by negative 9. Therefore, that becomes positive 2y is now equal to, since this is the constant and it is on the right side, we need to transfer that out to the right side, and that becomes negative 7. Okay, so we have 4. It is now the time that we complete the terms. X squared minus 4x plus 4. Since this is negative 4 divided by 2 squared, 4. Minus 9 times y squared plus 2y plus 1 is now equal to negative 7 plus 4 times 4. Okay, and plus 1 times negative 9. Okay, we'll be having 4 times x squared minus 4x plus 4, that is x minus 2 quantity squared, minus 9 times y plus 1 quantity squared is now equal to negative 7 plus 4 times 4, which is 16. So this becomes positive 9. Plus 1 times negative 9, that is minus 9. 9 minus 9, it becomes 0. Okay, in order for this to become or to somewhat look like an equation of the hyperbola, we need to multiply or to divide all the terms by, for example, the common factor. So we have 4 and 9, therefore we'll be dividing this by 9 times 4, which is 36. Okay, let us try to divide all the terms by 36. All the terms by 36. And we will be having 36 divided by 4, that is 9 times x minus 2 quantity squared minus, okay, 36 divided by 9, that is 4, retain y plus 1 quantity squared is equal to 0. And since the right side is just equal to 0, we could just rewrite this equation as x minus 2 quantity squared over 9 is equal to y plus 1 quantity squared over 4. So, it is not anymore a hyperbola. Therefore, it is two intersecting lines. Since the right side is equal to 0. And how do we get the equation of the line? Okay, we will now be using this equation. If that is the equation, so it is just like getting the asymptotes. Okay, so in this case, we have x minus 2 quantity squared over 9 is equal to y plus 1 quantity squared over 4. Okay, so since we only need the y value for this one, we cross multiply 4. Therefore, this becomes 4 over 9 times x minus 2 quantity squared is now equal to y plus 1 squared. Get the square root of both sides. Get the square root. Since we only need the y term, okay? This becomes square root of 4 over 9. That is plus minus 2 over 3 times x minus 2 is now equal to y plus 1. Okay? That is now y plus minus 2 over 3 times x minus 2. Transfer positive 1 to the other side. This becomes minus 1 is equal to y. Or we could say that the equation of the two intersecting lines would be y is equal to 2 over 3 times x minus 2 minus 1, and y is equal to negative 2 over 3 times x minus 2 minus 1. So this will now be the equation of the two intersecting lines. And in that case, if this is really a hyperbola, this is the equation of its asymptotes. So that is how we get the degenerate cases of a hyperbola. If you have questions, if you have comments and suggestions, please do not hesitate to message me on Facebook, on Instagram, or on my Twitter account. Once again, I am Engineer Judd Hernandez, saying that mathematics is always fun. Goodbye and God bless.